Welcome everyone to Systems Are Go. My name is Eric McLaughlin. I'm the astronomer for the Rancho Mirage Library and Observatory, and this month, the month of August 2020, we have a few really interesting things to point out from the data we collected here. We're actually going to start on July 22nd, where we actually finished off last month. On the 22nd, we actually had a really interesting thing pop into our sky. You probably missed it. I know I did until it was pointed out by our Global Fireball Observatory camera. So we'll stop the video right here. That thing you see over on the left side of the screen, that little streak, that is a pretty decent sized meteor entering the Earth's atmosphere. And as it was captured by the Global Fireball Observatory camera, we have another image of it here. Now, as its name suggests, the Global Fireball Observatory is not just one camera locally here. It is a global network of cameras that actually started over in Australia. The western section of the U.S., the coordinator for that is Dr. Peter Jenniskins, who is up at the Ames Research Center with NASA and with the SETI Institute. And heading up operations in our area is Jim Albers. So when I say that the GFO camera let us know about this, what I really mean is these two really were the ones who let us know, because they're the ones actually operating and monitoring all the cameras in our area. And when I say all the cameras, there was another camera that actually caught this object over in West LA. Jason Utas has a camera at his residence, and this image here is what he caught. You'll note that there is a little bit of a difference between this image and the image that we caught. Why is there a difference? Well, because of a change in perspective. That change in perspective allows for some interesting calculations. Hadrian de Villepoix of Curtin University over in Perth, Australia, analyzed these images and calculated that this object was about 0.77 kilograms, so it was pretty light as it entered the Earth's atmosphere, but still was moving at quite a reasonable clip, going about 19.5 kilometers per second when it was about to enter the Earth's atmosphere. And as it burned up, it went from that 0.77 kilograms down to around 10 grams when it stopped glowing nice and bright for us there. And at that point, it actually slowed all the way down to about 8 meters per second, going much, much slower. At that point, that little 10-gram thing, whether or not it really actually survived as one solid object or if it fragmented, it's going to be kind of hard to find it at all. Well, in fact, it probably won't be able to be found because it actually likely fell off the coast of Encinitas up to around Carlsbad area. And so, yeah, I wouldn't go hunting for this one. Nevertheless, this view here is the result of all those calculations, and it is really great to be able to be working with the Global Fireball Observatory. We've got their website linked below, and if you happen to spot a nice big bright meteor, you can actually report it at the American Meteor Society website, also linked below. We're going to go ahead and transition back into our time lapses, so we'll get it going right now. But we will come back to meteors in a few moments as we got another detection in August. So, I will be back shortly. stop. All right, you see that right there? That is yet another one of those big bright meteors being captured by our all-sky camera. And as you can see in this image, it was also captured by our Global Fireball Observatory camera. This one was also captured by Jason Utas's camera over in West LA, but it was also captured, shown here by Bob Lunsford's camera down in El Cajon, as well as all the way out at Tehachapi at Sean Spratt's camera there. I haven't seen the detailed calculations on this one yet, but based on how it entered, it looks as though it likely wasn't one of the Perseid meteors that came by. Yes, we were in the midst of the Perseid meteor shower when this one hit. However, this one's particularly slow apparent speed indicates that it may not have been one of the Perseids. All right, let's keep on going. Now let's go over some of the weather data we recorded over the past month or so. Looking here, we have our max and min temperature and humidity plots for both July and August, at least August thus far. And these show what you've been feeling. It's pretty expected. Again, we've got Celsius on the left and Fahrenheit on the right for our temperature plots, but humidity is an interesting thing. It's worth noting how humidity works. Again, hotter temperatures allow for greater water content, and so that's why we use the term relative humidity there rather than water content. So, how are these graphs actually interrelated? Well, let's take a look at when we see high temperatures. This graph here is basically a folded daily plot where we have the date on the x-axis, so every column of squares here is a different day, and every row represents a different time. As the day moves on, you go up a given column. And with this particular view here, you may not notice that much because this color mapping is scaled based on expected temperatures throughout the year. But if we make it a little bit more sensitive and set the color map like this, where it's just more around the maximum temperatures of that given month, you can see a bit more variation. And you can really start to see some of the patterns there. In particular, you can see the coldest time of the day tends to be just before sunrise, around 5 to 6 a.m., and the hottest time of day comes in the mid-afternoons around 3 to 6 p.m. Those time frames really do tend to be consistent across the month, and we'll see as it goes on around the year just how those things will vary. Now, how do these graphs relate to the relationship between humidity and temperature? Well, while water content throughout the day does shift a bit, it doesn't actually shift as much compared to the temperature, and as such, the relative humidity on a given day and the temperature are rather related. So, if we're looking at the highest temperatures, that's when you expect the lowest humidity. And if you're looking at the lowest temperatures, that's when you expect the highest humidity. So what happens if we actually plot the humidity, the relative humidity versus the temperature? Over the course of about February to August, we can make a good plot, and this is what we get here. This nice colorful plot shows a lot of interesting patterns on it. In particular, you can see our humid season, at least percent humidity-wise, actually comes to some extent in more of the cooler times. And that's simply because we are actually closer to that dew point in the early morning hours. You can still see, because of that diagonal line that a given color makes, in the hottest part of the day, even in the winter, we get very low, near 10% humidity on some days. But right now, one of the big things we'll note is while we have our high humidity still being at the coolest time of day, some of those yellow points there, even the most recent ones especially, the coolest time of day is still at a temperature over 30 degrees Celsius. 30 degrees Celsius comes out to about 86 degrees Fahrenheit, so it is still really warm in the mornings, which means our mornings are warm and very humid relative to any other time in the year. And so we really feel it quite a bit throughout the day as well. And with that, we will transition into our solar telescope time lapses. For this time frame, we had some technical and other difficulties, so there will be a fewer days worth of images here. Nevertheless, we also have some really interesting things, as we did have some sunspots over part of this past month. They were very minor, and what you'll notice more here than the sunspots will actually be the plages, the brighter regions around them. The other thing you're going to notice a lot of is some of those little technical difficulties we left in here so you can see some of what we were seeing. And you'll also get a chance to see quite a bit of cloud cover on some of those days. And with that cloud cover comes a bit of dramatic shifts in brightness. So this is one of the areas where we have the main potential for flashing lights. So a bit of a seizure warning for anyone. But yeah, enjoy these time lapses, and I'll touch base with you as we wrap up. And that's all we have for you right now. At this point, I want to give a special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're able to offer all of our programming. So again, a special thank you to the foundation. If you're interested in looking into the foundation, recommend checking out our website linked below. If you'd like to get emails regarding when we have different things going on here at the Library and Observatory, you can sign up for our e-newsletter at the link also placed below. Furthermore, if you'd like to get notified right here, please subscribe. Let us know what you think of this video, and we hope to see you again here real soon. Have a great night, everyone.